Hi everyone, my name is Supriya Paudel and today I'll be presenting my data mining project on forecasting Walmart store sales. So as we all know that Walmart is one of the largest retailers in the world and managing its weekly sales effectively is critical to operations. And accurate forecasting can help in inventory management, staffing decision, promotional planning and overall profitability. Moving forward to introduction, my project focuses on building predictive models using the data to improve decision making. Also, good forecasting can prevent issues like overstocking, understocking, and inefficient labor scheduling. My goal is to extract insights and build models that Walmart could actually use to optimize operations. Talking about background research, I explore different forecasting methods like naive forecasting as a simple baseline, moving average models to smooth data, or ARIMA for more advanced pattern detection. So, based on literature review and performance, ARIMA was chosen as it balances simplicity, flexibility, and strong forecasting. Talking about the problem presentation, the challenges is that Walmart sales is not steady. So they spike during holidays like Christmas, Thanksgiving, or promotion like Black Friday. Also, sales data shows seasonality, upward or downward trends, random noise from unpredictable events, and non-stationary behavior where the mean and variance change over a time. So the main problem was how can we build a model that deals with all these factors while remaining accurate or future unseen weeks. Specification and design. The design of the project was systematic, and first I aggregated sales data across all stores to create a single national-wide weekly sales series. Then I structured the data to date and verified there were no missing weeks. And I split the data into 80% for training and 24% for testing to stimulate predicting future data. Also, the forecasting methods I implemented were the naive method of 4 week simple moving average and auto RMA. This pipeline ensures that results are predictable and transparent. Talking about data acquisition, data came from Kaggle, a very well-known source for data sales datasets. The datasets spans from 2010 to 2012 and includes weekly sales figures, external variables like temperature, fuel, price, CPI, and unemployment, and a holiday flag indicating weeks with major US holidays. These extra economic and event based variables are crucial because they influence consumer behavior significantly during certain weeks. So, data exploration. Before modeling, it was important to explore the data visually. I plotted the raw weekly sales and applied 100-week and 200-week moving average to highlight longer term trends. The raw data showed sharp fluctuation, clear spikes around known holidays, and the moving average smoothed out the noise, showing an underlying stable sales trend with only minor dips and recoveries between 2010 and 2012. So the exploration confirmed that the need for models that could handle both trend and seasonality. So the next step is data transformation. So I conducted a stationarity check using the ADF test, and the original time series was not stationarity. That means its statistical properties varied over time, which violates a key assumption for ARIMA models. So to fix this, I applied first order differentiating, subtracting each cell's value from the previous week cells. After differentiating, the ADF test confirmed the series became stationarity, making it ready for ARIMA modeling. So even though autoarima in R is not like it cannot be automatically handle differencing. So verifying the manually ensures model in correctness. So I use that. So talking about avoiding overfitting prevention was crucial. I split the data into a training and test set to validate generalization. I used AutoArima to automatically choose optimal parameters PDQ by minimizing information criteria like AIC and BIC. After training, I checked residuals. Residuals look like random noise, which is idle, and the ACF plots shows no remaining autocorrection. This means the ARIMA model successfully captured the structure in the data without memorizing any noise. So for model tuning, I use the AutoArima function to automatically select the best parameters PDQ based on minimizing AIC and BIC values, as I mentioned earlier. This helped balance model accuracy and complexity. I also applied differencing to make the data stationary, which is important for ARIMA models. After training, I checked residuals with ACF plots to confirm there was no remaining autocorrect correlation. This process ensured that model was well tuned for accurate future forecasting without overfitting. So for model result visualization, the visualization played a huge role in analyzing model performance. I plotted actual versus predicted sales lines to visually inspect fit. ACF plots and histogram of residual checked whether errors were random and normally distributed. Forecast graphs compare naive, ARIMA, and ETS models. From this, it was clear that ETS handled holiday seasonality better, but ARIMA performs strongly on trends. So as you can see in the figure, the residual from the ARIMA model applied to Walmart's weekly sales data mostly fluctuate around zero, with a few sharp spikes suggesting minor volatility that the model did not fully capture. The ACF plot shows the residuals are approximately uncorrelated and indicating a good overall model fit for Walmart sales trend. The histogram reveals slight weakness and heavier tails, suggesting minor deviation from normality. Overall, the model captures Walmart cells behavior well. Through occasional extreme fluctuation, we meant that could be addressed for within the further refinement. Motivation for a theoretical choice of technique. For this project, ARIMA was selected because of its strength in handling time series data that exhibit both trend and seasonality. It models past observation trends and moving appraises, making it well suited for Walmart sales, which shows clear seasonal patterns around major holidays and promotions. Also, ARIMA exponential smoothing was also chosen. This method focused more on the recent sales data, making it ideal for short-term forecasting where the most recent patterns are critical. So I was able to address Walmart sales challenges related to trend detection, seasonal spikes, and short-term fluctuation also. Talking about the results, the final results of ARIMA model is like MAP is 6.96 percentage, which is quite good considering Walmart massive sales volume, and RMSE is 5.96 million dollars, and MA is around $3.47 million. So although ARIMA slightly unpredicted sales during high seasonal peaks, its overall performance was reliable and accurate, especially for regular peaks. And the given scale of Walmart sales, these forecasting errors are quite acceptable. So here is the conclusion that the ARIMA model was the best choice for trend and general forecasting. The ETS model better captured holiday seasonality but was more complex, And forecasting weekly sales accurately has massive value for Walmart. It is like smarter inventory ordering, better staffing, and also it works for like timely promotions planning. So further improvements could include like incorporating external variables like CPI and unemployment rates, which is directly into the model to increase forecasting accuracy. So coming to the end of the presentation, I want to thank you for listening, and I'm happy to answer if you guys have any question regarding it. And I will also like place the YouTube link for this full presentation. Thank you.